Hello class 11. In our last class we discussed about Dalton's atomic theory, and after that we have seen its limitation, and then at the end we discuss about Avogadro's law. Now today we are going to discuss about laws of chemical combination. So the fundamental laws that involves in the chemical combinations are: the first one, law of conservation of mass. The second one, we have got law of constant composition or definite proportion. Third one, we have got law of multiple proportions. Fourth one, we have got law of reciprocal proportions. And the fifth one, we have got Gay-Lussac's law of gaseous volume. We need to discuss one by one the statement, explanation, and with examples. So first we are going to see law of conservation of mass. We are very familiar with this law, and the statement tells us matter is neither created nor destroyed during any physical or chemical change. So according to the law of conservation of mass, matter is neither created nor destroyed during any physical or chemical change. That is one form of the law. In other words, we can also state as the total mass of the reactants before the reaction is equal to the total mass of the product after the reaction. That means before the reaction, whatever will be the total mass of the reactants will be equal to the mass of the product, total mass of the product after the reaction. Total mass of the product. Now, in case of physical change, we have got ice converting into water. It's a physical change. Over here, if you take ice in a closed container and if you apply heat, it will convert into a water or liquid form. Now, the mass of the ice before the reaction and the mass of the water after the reaction, after the change, if you just compare, you'll find both the mass same. Next, in chemical change, a new substance is formed, as we know. So the law of conservation of mass can be verified by the study of precipitation reaction, one type precipitation reaction, and it is mainly known by a new experiment, Landel's experiment. Let us try to understand this experiment, how it has verified law of conservation of mass. So in Landel's experiment, he has taken an H-shaped tube as shown in the diagram, and in one, so they are connected with each other through a tube. Now in one tube there is a sodium chloride solution, and in another tube we have got silver nitrate solution. Now we'll take the weight of the tube along with the solution before the reaction. Say for example the weight comes as W1. Now what we'll do, we'll just shake the tube so that the solution from sodium chloride solution will go and mix with silver nitrate solution, and the solution from silver nitrate will go and mix with the sodium chloride solution. So after the reaction occurs, you'll find that silver chloride plus sodium nitrate is formed. Silver chloride is a white precipitate. So since a new substance has been formed, we can call this a chemical change. Now you'll find that a white precipitate in both the tubes. Now what you do is you take the weight of this tube along with the solution and note down the weight. You'll observe that the weight before the reaction and after the reaction is same. So this experiment verifies law of conservation of mass. Next, we have got the second law, that is law of definite proportions, or we call law of constant composition. Let us see this one. According to the law, A pure chemical compound, regardless of its source, is always made up of the same element combined together in a fixed proportion by weight. We'll understand this statement by taking an example. Say for example, if you take water, regardless of its source, say for example you can take tap water, river water, sea water, or any kind of water. Now in this water, the composition of hydrogen and oxygen combined together is in the ratio of 1:8 by weight. Is 1:8 by weight. How it is 1:8? Water H2O, if you find the ratio H and O, we have got two hydrogen atom and atomic mass is 1, so 1 into 2. Oxygen atomic mass is 16 into 1, so it will be 2:16. When you cancel it, it becomes 1:8. So any water source, whatever if by the source, the water in water, the composition of hydrogen and oxygen combination is always in the ratio of 1:8 by weight. Another example we'll take carbon dioxide. Carbon dioxide can be prepared by various methods. Say for example, calcium carbonate on heating will give you calcium oxide and carbon dioxide. Carbon plus oxygen can give you carbon dioxide. Calcium carbonate plus hydrochloric acid can give you calcium chloride plus water plus carbon dioxide. So there are different methods. Now, whatever mean the methods of production of carbon dioxide, the carbon dioxide always contains carbon and oxygen element in the ratio 3:8 by weight. 3:8 by weight. Now how it is? Say for example, in carbon dioxide, carbon is 1 and oxygen is 2. So atomic mass of carbon is 12, so 12 into 1 because of number of atom is 1, and oxygen atomic mass is 16, so into 2, that is 32. So 12 is to 32. When you cancel it, it cancel with 4, 3, 12, and 4, 8, 32. So you'll get the simplest ratio 3:8. So this verifies law of definite proportion, or we call definite composition. Now, a pure chemical compound, regardless of its source, is always made up of the same element combined together in a fixed proportion by weight.